We are starting the session in 1 minute. And also, there is one question that is there any session for the exam for this course? Yes, there will be. On Saturday, we are having one revision session. Means ki whole overall what I have taught or the overall course, we will do the revision and solve few of the problems related to that, which will help you in the for solving the question in the examination.
Hello, can you hear me?
Yeah, yeah,
I'm not too worried about the questions, but the calculator, right?
yeah,
It's very cumbersome. Like it's if the especially in the polar, the
yeah, yeah,
phasor, and all those things,
yeah.
conversion like is very tough. In the is there any hack in that calculator using that memory thing and all that you have discovered, or if you
Oh,
can?
no, no, no. There is a actually, for the examination perspective, the NPTEL actually handles that kind of issues, and we are just to deliver the means solve the tutorial sessions and give you some
Okay.
glimpse which is related to the assignments and all. Okay,
Yeah, I'm sorry. I'm sorry.
okay.
So, is
It,
there anyone I can directly mail
yeah,
or contact? Because it's
from
you
where
know,
you are getting the mails from the NPTEL people,
okay,
directly you can talk to them or email to them directly. Okay.
okay, okay.
Okay. Okay.
Thank you.
Okay. So we are starting this 12th tutorial session. This is a last tutorial session related to this assignments part, and one will be having the revision session on the Saturday from 6 to 8. And so we are starting the 12th tutorial session, and this of the network analysis, who is instructed Professor Tapas Kumar Bhattacharya sir. I am Satya from Department of Energy Science Engineering, IIT Bombay, PMRF research scholar. Okay, so we have seen a few of the problems related to this two-port networks and all. So, which could help you to solve the assignment, this 11th assignment basically. So we will see a few of the problems which I have given some glimpse related to op-amp problem of the assignment 12. Okay. So if you see the what is actually the ideal op-amp circuit looks like, if you see that means you having the three terminals here, means general op-amp circuit, you having one terminal as a positive terminal, one terminal as a negative terminal, and you have this output terminal here where the current I output is falling. Okay. And this A, if you can see that this is actually the V output is equal to A times of V positive minus V negative. This A is called as a gain. Gain basically most of the time it is very high, so that's why we neglect. Suppose V A is equal to V output divided by V positive minus V negative. That if it is a actually very high, in that sense, if you see V output is nearly very high, so we can neglect this part. Means some most of the time we consider that V positive is nearly equal to V negative, kind of. Okay. So if you see the generalized control source model in the B part, it is simply will be okay, you can represent. Suppose this is the R naught here representing here the uh, input. If you see our input, it is very high. So that's why we consider that it is in the mega ohms most of the time. That's why we consider that the current which is flowing into this register is very low, or you can neglect or consider it as a zero. That's why if you see that V positive minus V negative, this is a potential difference, and the current which is flowing and it times of the R. If R is very high, or you can say the current which is so that the current will be very low. Okay, in that sense this V positive minus V negative becomes nearly equal to zero, or you can say that V positive is nearly equal to V negative, kind of. Okay, and which is being reflected on the output side, that is a gain times of V positive minus negative, whatever the potential difference being applied. Okay, there is a one few things you have to remember for solving this tutorial session, that current which is flowing each in the each input lead is zero. whatever I have told, because the gain is very, very high and the input impedance which is coming, which is J input from the source side, it is very, very high. That's why the current which is going input into the input lead, it is nearly equal to zero. Okay. So if you suppose I take this circuit, suppose the A circuit basically. Here, if you see, there are two terminal. This is the V negative, and here, which is grounded, this is the V positive. Okay. Ideal circuit look like something like this. So this is the R naught basically inside. So if I'm considering that R naught is very, very high, it is in the mega ohm. So that's why the current which is flowing into that, it is zero. That's what is the meaning of that. It means that the whatever the current which is flowing from the input side, it will directly move from the feedback to the output side. Okay. There will be no current which is going into the negative terminals. Okay. That is the meaning of the ideal means input lead, which is current which is going into the input lead is nearly equal to zero. And also that the output voltage is independent output of the output current. That is the meaning that whatever the circuit looks like, suppose this, if you see this circuit, first circuit itself, this V output is not depending upon the input current. What we can say that, suppose this is the V output and the V is here it is coming. So some current will flow from here itself and also some current from the I input side. Okay. So it is not directly related with the V output. It is actually the summation of that. Okay. Suppose you can see that this output lead basically, this is the gain times of V positive minus V negative. That's meaning that it is dependent upon the whatever the input you are putting. That's why output voltage is independent of the output current. And also gain A, which is it is not miss actually the independent about, it is not a function of the frequency basically. It is just a constant. Suppose I'm saying 100, I'm saying 1000. So these are the basically gains which is representing that V output by V input is the means in output is the 100 times of the V input or 1000 times of the V inputs. So it is independent of the frequency, and the voltage gain A is very, very large, approaching infinity in the limit, which is I'm saying the ideal condition is that A is infinity, but it is in very, very high some most of the time. Okay. So ideal op amp, if you see, this is the actually the circuit that you having the negative terminal, you have the positive terminal, we have the output terminal. Also, one more thing you have to see here, VCC and the VE. VCC means this is the V set positive saturation voltage and V set negative. Why I'm saying that V set or the V minus V set, you can remember from the here ideal circuit here. Suppose I'm saying that there is a no saturation. No saturation means there is a minus V side will be the one output. If the what is the V output? V output is basically A times of V positive minus V negative. Okay. If V input is very, very high as compared to the V positive, it means that V output will be negative. Okay. If V output is negative, it means that the value will be minus V side. There is a no in between values. There is a two values only. Either it will saturate in the positive direction, or it will saturate in the negative direction basically. So if V negative is very, very high as compared to the V positive, it means that it is negative and the value of the V output will be minus of V side. Okay. If the V output is very, very high as compared to the V negative, then its value will be the plus V side. There is no in between values. So these are the condition for the ideal op amp. Okay. If we go for the non-ideal scenario, suppose I'm taking the right size image, non-ideal scenario, there is a one linear region, okay, where this V output, or you can say that V output, this is the VD basically, whatever voltage you are applying from the positive side or negative side. So V output is A times of V positive minus V negative. So in between this linear region, there could be any value in between the minus V sat to the V plus V sat. If V output is greater than this positive value, means suppose V sat value is the 12 volt and you got the output as 18 volt, then the 18 volt will not be the output. Output will be the 12 volt because the 12 volt is the saturation voltage. So at that particular voltage, it will get saturated. So two things you have to remember that. So in the ideal scenario, ideal scenario, you have the only two voltages, plus Vsat, it will be given in the picture, and minus Vsat. And in the non-ideal scenario, if V output is greater than the value which you have got, so you that in that scenario output will be the plus Vsat, and if V output is less than the negative terms whatever you have got, it is less than that, so then it will be minus Vsat in the ideal scenario. In between means in between the minus Vsat to the plus Vsat, there will be output. You can expect any values. Okay. So these are the important things. And important thing here is to solve the problems. Suppose I take the assignment problem. Let me take the assignment problem directly here. Suppose I am taking this assignment problem. This is the first assignment problem. And if you see here, the this is an ideal scenario, ideal non-ideal scenario. But you can see that this is the plus V sat here, and this is the minus V sat. And the voltage, this is the input voltage which is being applied. It is being applied to the positive terminal. Okay. Negative terminal, it is actually reference to the ground, not directly, but in between you have the 5 volt and the 10 ohm, but negative terminal is actually grounded. Okay. So how to check whether it is a inverting circuit or non-inverting circuit? So let me jump to the how to check basically. If you see in these problems, where the positive voltages means input voltage is connected, suppose V input here, it is connected to the negative terminal, it means that it is a inverting circuit, inverting op amp. Okay. Whatever circuit you see, suppose in the B part, if you see that where the V input is connected, it connected to the negative side, it means that it is inverting op amp. If you see the C option means the C circuit, here also it is connected to the negative circuit, it means that it is a inverting. Let's take the other examples. Suppose I take this. Here also the V, where is the V input connected? To the negative side. That means that it is a inverting amplifier. Let's take the other. If you feel any doubt in between, just ask me. Ask me if you're facing any doubt related to that. Okay, so that I can make sure that you should check whatever things doubt you are getting. Okay, let's take the another circuit. Here also, if you see here the negative terminal, V input is connected to the negative terminal. It means it is an inverting amplifier. In this problem, here the V input is also connected to negative terminal. It is also inverting amplifier. Let's take the non-inverting example. If you see here the V input is connected to the positive. It means that it is not an inverting circuit. It means that it is a non-inverting circuit. Okay. Just basic to how to check whether a op-amp circuit is inverting or non-inverting. If you see this example, here also the V input is connected to the positive terminal, not at the negative terminal. It means that it is a non-inverting circuit. Same with the other B option as well. Here also the Vs is connected to the positive. Okay. Then how to solve this means important point is that to get the most of the question you will get the what is the ratio of the V output by V input, or you can get the ratio of the V output by I input. These are the major type of problems which you can expect from this topic. Okay, so there is a one concept known as the virtual ground concept, which is very important to solve this kind of problems. Virtual ground concept. Okay, let me explain by taking a new slide. Okay, virtual ground concept says that suppose you have one op-amp circuit, this is a positive, this is negative terminal, and I'm considering that it is a inverting basically. So that's why I've connected Vs, the input source voltage, to the negative terminal, and then I have connected one uh, positive terminal I have grounded, and this is the V output basically. Okay. The virtual ground concept says that whatever, suppose the source voltage is connected to the inverting side and you have the other side grounded, then it means that because the what how the circuit looks like, its circuit ideally look like this. This is the R input. What we have studied is that no current will flow through this resistor. Why? Because it is the very high value. That's why no current will flow into the circuit. It means that if the current is not flowing in this circuit, it means that they are at a same potential basically. Are you getting my point? It means that they are at a same potential, not saying that it is short circuited basically. I'm saying that it is at a same potential. That's why no current will flow. Suppose V output is equal to A times of V positive minus V negative, okay? And the current will be flowing whatever through the R naught, it will be V positive minus V negative divided by R basically, okay? I'm saying that the current, if the resistor is very, very high, resistance is very, very high, it means the current will be zero. If it means that if the current is zero, the V positive will be nearly equal to V negative. It means that whatever the positive voltage you have, whatever you have applied at the negative terminal, that same will be reflected at the negative side. It means that Vs will be nearly equal to zero. Whatever the source voltage you applied, it becomes zero because will be no current which is flowing into the circuit because of the R naught is very, very high. Okay. And Vs you have to take it as a variable. Okay. Shankar, if
Yeah,
you,
yeah.
yeah,
So this is this correct explanation? Because see, between ground and the terminal, the source will always force a potential of Vs. How
yeah,
can the Vs be forced to zero? Like
no, no,
if
no, 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 no.
what I
Here,
understand
though,
is like,
so this is just a example circuit. Most of the time it will have the feedback.
feedback.
That's,
If the feedback is there, definitely like what you are saying is like
yeah.
yeah, what will
Yeah,
happen?
yeah,
Because the drop, right? Like so,
yeah.
VO can be forced to ground, and yeah, okay, you can we can continue.
Yeah, I'm just saying कि this is just a circuit which I am taking. I'm just saying that कि Vs is variable. That's why it became zero. If Vs is not variable, then it will not become to zero. Okay. Based upon that, whatever the resistance path is there, suppose this is very, very high, no current will flow. It means that कि source which you wanted to apply, it will be nearly equal to zero. Okay, it will be very, very low. But just a theoretical circuits which I am taking. Okay. Let's take the few of the circuits like this. Suppose first circuit, A circuit I have taken. Here the if you see the positive terminal, I have applied 0 volt. Okay. Through the virtual ground concept, the same voltage will be reflected at the negative terminal because it don't have any, it have the very high resistance, so no current will flow into the circuit, into the negative terminal or into the positive terminal. That's why the current is zero, so all current will flow like this. Okay, and this zero voltage will be reflected at this point. This will be also considered as a ground. Okay, that's why because it became easy. So how the circuit will look like? Suppose this you have already grounded, okay, through the virtual ground concept, and this is the feedback, that is the RF, and which is coming here. Here the op-amp circuit is there, some current will flow, and you have connected R naught, and you have this V output. Okay. What I'm saying that apply the KVL, apply the KCL here basically, apply the KCL in this circuit. This is already being grounded. So when you apply the KCL, how it will come out to be? This is 0. So 0 minus V input divided by R1 plus 0 minus V output divided by RF will be equal to 0. Okay. V output will become minus times of RF by Ri times of V input. Okay. This is the same concept which I have told that ki if the input voltage is connected to the negative terminal, it is a inverting amplifier. It means that whatever the input voltage you will apply, it will get inverted. Means suppose I have connected a sine omega t term at the input side, then V output will be the out of phase of that circuit. Okay. This is a concept that to say that it is an inverting amplifier. Whatever you will provide, it will 180-degree phase shifted. Okay. If you see the B circuit also same circuit, but only thing is that it is connected to the RL here. This will not get affected, same output you will get. Okay. Any doubt in this, in the virtual ground concept? This is the same simple circuit that apply the virtual ground concept and based upon that try to solve the problems. Suppose this is also 0 here, apply the 0 here, and then apply the KCL at that particular point, and then try to solve the problems. Okay. Any doubt in this? If you don't have doubt, try to solve this. I wanted to know the gain of this circuit. Try to solve and let me know what is the output gain of the. A gain is basically V output by V input. Try to solve and let me know what the output you are getting. Apply the same concept that positive terminal, whatever the voltage you have applied as the positive side, reflect it to the negative side, consider and apply the KCL at that particular node. Suppose this is the node, apply the KCL at the particular node A and try to solve.
Yeah, so it will be
Hmm.
minus R2 parallel C by R1.
Yeah, yeah,
So
exactly,
V1
exactly.
minus 0, V1 minus 0 is equal plus 0 minus V0 divided by the impedance will be like 0, like
Yeah,
KCL.
exactly,
KCL.
exactly, exactly. So it means that ki whatever you have applied as the positive side can be reflected to negative side, and this A terminal will be mm, grounded, means through the virtual ground concept, and then you apply the KCL at the node A. It will become 0 minus V input divided by R1 plus 0 minus V output divided by R2 parallel times of C is equal to 0. So what you got at the V output? V output will be simply equal to R2 parallel to C divided by R1 times of minus also, and here is the negative. So this is actually the RF. RF means RF is the feedback. Whatever you are applying, what is connected from the input side to the output side, this is the feedback basically. It can be a capacitive circuit, inductive circuit, and based upon whatever application you wanted to use. Okay. If you got this concept to apply the virtual ground concept, try to solve this problem. This easy problem. Let me know what is the answer.
Sir,
Yeah.
can't we write V1 minus 0 by R1?
Yeah, that's true. What the thing is I do, I always assume that the current is leaving that node. Okay. I always assume that ki summation of I is equal to 0, and always I consider that ki current is leaving that node. If you take that also, that Vi minus 0 by R1 plus V output minus 0 by R2 parallels to C, then there will be no difference on that. You then in that sense you will consider that the current is entering the node. Okay, the output will not be get affected by that.
Okay, sir.
Yeah, try to solve this.
Option 4, sir.
Option 4. Okay, give one more minute to others also to solve. Then we will see what is the correct answer. This simple problem which I have given that gain value, that is simple formula. Okay, let me give the solution for this, and after that we will see the important problems. Okay, so what I have told that gain is actually equal to V output by V input simply, and V input can be, that is the V positive minus V negative sense, and then the gain here it is given as a 500. Okay, that is voltage gain, and V output is given as a 5. So the what is the value of V input? V input will be simply 5 divided by 500, or you can say that 10 millivolt. Okay, so the option 4 will be the correct option. Okay, any doubt in this? Just a formula based problem. Okay, let's move to the important problems which is there for the assignment. Try to solve this. If the one terminal is not grounded directly, assume some voltage of that. Suppose here it is A point is not grounded directly. Okay. So assume some voltage, suppose I have assumed V dash. Okay. And try to make a two equation out of that and to buy for removing this V dash. Okay. So V dash will be appear here. Similarly will appear at the terminal B also, and then try to solve that problem because no current will flow here, also no current will flow here. Okay, make it two equation and try to solve. Okay, option 4 I got. Okay, let's give some more time to solve for others also. If you face any doubt in between, just let me know. Okay, I will clear the doubt. Okay, use that same concept, assume some voltage at that terminal and make it two equation and solve. Okay. And those who have given the answer, re-verify whether it is correct or not. Okay, that's more important. Whatever you are giving, it should match the correctly.
Option 4, sir.
Okay, option 4, I got the second answer also. Okay, let me solve this. And, suppose here it is the terminals are not actually correctly grounded, okay, directly connected to the ground. So I thought that we should assume some voltage here, V dash. Okay, if you see the downside terminal here, this circuit, if you apply the KVL at this point, it will be simply V dash plus 2V divided by R plus V dash minus, let's assume that this is a X voltage, okay? Or you can directly use that 2 plus sine 100t divided by R is equal to 0. So it will be simply the 2V plus 2 basically here. So the 2 will get cancelled out here. So it will become 2V dash equal to sine 100t here. or you can say that V dash is equal to 0.5 times of sine 100t. Okay. Apply the KVL in the upper loop. Upper loop means कि this circuit, because no current will flow into the negative terminal. Apply there. So you will get V dash minus 0 divided by R plus V dash minus V output divided by 2R is equal to 0. You can say that it will become 3 times of V dash is equal to V output. Okay. So V output, so 3 times of V dash. Okay. That is true. V dash minus 0 divided by R plus V dash minus V output divided by 2R is equal to 0. So it will become 2R, 2R here. This will be 3 V dash is equal to V output. That's correct. So V dash, what we have got here, V dash is actually 0.5. When you multiply V output, it will become 3 times of 0.5 sine 100t. So it will become 1.5 times of sine 100. Okay, so the correct answer will come out to be option 2. Any doubt in this? See the answer correctly. Okay, so it's a not, we are not in a hurry. We just have to grasp the what is the actually the correct values. Okay, apply the KVL in the two loops and then see that okay, what is the correct values. Okay, any doubt in this? Okay, let's move forward. Okay, always see that key whether it is one terminal is grounded or not. If it is a grounded, then assume that the same potential will fall at that positive. If it is at the positive terminal, it will be reflected at the negative side, and then apply the KCL basically at that particular node. And if it is not given, assume some voltage and then apply the KCL. Try to solve this. Here it is already grounded. Okay, then it becomes easy. But here you have to assume few more voltages. Suppose here the node voltage is not given. Okay, then you have to assume some voltages here and make one, two, two, three equations, and then you have to solve it. Okay, -4, I've got one answer. Uh, let's wait for others also and also verify your answer. Okay, try to re-verify whether -4 is correct or not. Okay, your voice is not clear. Can you repeat, please? 9. Okay. Re-verify whether it is correct or not. After 1-2 minutes, we actually solve the problem. Re-verify whether it is correct or not. Okay. Correct answer will come -8. Okay. Check where you are facing problem. Okay. Where it became wrong. Take 1 minute more. Okay, listen here. I'm going to solve this problem. Okay. Listen here. See the procedure, how actually I'm following. What I have told through the virtual ground concept, whatever the potential which is appearing on the positive terminal will get reflected at the negative side. Okay. Here it is directly grounded. It means that it will be at a virtual grounding. Okay. So let's apply the KCL at that particular node. Okay. There is a 4 nodes. Node A here, node B here, node C here, and this is the output terminal already. So this is the output node. Okay. If you apply, suppose because we don't know the voltage as the B and C nodes. Let's assume that it is at V1 and here it is at V2. Okay, C node voltage is V2 and the B node voltage is V1. Okay, let's apply the KCL here at node A. Let's apply the KCL at node A. It is already 0, so 0 minus V input divided by R plus 0 minus V1 divided by R is equal to 0. Then it will become simply like this. V1 is equal to minus times of Vi. Okay. First equation. Let's apply the KCL at node B. When you apply the KCL at node B, it will become 0. Not 0. Here the voltage is V1 basically. So the V1 minus 0 divided by R, because the node A voltage is 0, plus V1 minus V2 by R plus V1 minus 0 by R, this side current, okay, is equal to 0. From here you will get the equation like this. in relation between the V2 and V1. So V2 will become equal to 3 times of V1. So this is the second equation. So let's apply the KCL at node C. When you apply, you will get V2 minus V1 by R plus V2 by R plus V2 minus V output by R is equal to 0. Or you can say that V output is equal to 1, 2, 3. 3 times of V2 minus V1. Okay, this is the third equation. Put the values because we wanted the output means answer in terms of V output by V input. Okay, let's put the equation means value of equation 2 in equation 1. Then it will become V output is equal to 3 times of V2 value is 3 times of V1. Okay, minus V1. It will become 8 times of V1. Okay, then put the value of equation 1 in this equation. Suppose this is equation 4. Put in equation 4. What it will become? We have already got the V output is equal to 8 times of V1. And equation 1 says that V1 is equal to minus times of Vi. Okay. So V output will become minus 8 times of Vi. So what will be the value of V output by V input? It will be equal to minus times of 8. Okay. Any doubt in this? I think you have done some of the calculation mistake which you have got that minus 4 or something. Okay. So calculation part is very important here. You cannot rely on the if you are solving the grade problems and all, there the accuracy matters more than the means speed basically. So you should re-verify whether it is minus 8 is correct, minus 4 is correct, or 9 is correct or not. Okay, this is very important thing to remember for the gate also. Okay, and for this exam as well. Okay, any doubt in this?
No, sir.
Okay, let's move forward. Okay, let me give you one good type of question. Suppose I have given this. Here the V input is, in this question, the saturation voltage is given. Saturation means if suppose V output you got the 19 volt, okay, but the saturation voltage is given as plus minus 15 volt, okay, then your output will be equal to 15 volt, not 19 volt. Why? Because if you see the circuit which I have told, your 15 volt, suppose the V sat is 15 volt and here it is minus 15 volt. If your output, so this is the V input, this is the V output. If your V output is greater than the 15 volt, suppose here you got as a 19 volt, okay? So there is a no 19 volt. If after the 15 volt it gets saturated, okay? It means that you will never get the value voltages higher than the plus V set or less than the minus V set. Okay. It could be in between. It could be in between plus V set to minus V set any value. But if the saturation voltages are given, then you have to use that particular voltage. Okay. You have to see the output is actually matching or not. Okay. Use this concept and try to solve this problem. V input is given as minus 3.5, minus 3.5. This is a good question, but you have to use 2, 3 equations basically. You have to apply, suppose here the voltage is not given, assume something, apply something here, and then you have to apply here as well. Okay. Whatever the V01 you will get, reflect it to this node. Then you will get the V output value. This is the 2 op-amp circuit basically.
Seven, sir.
7. Okay. Verify again. And whatever the output voltage you will get at V01, okay, you have to solve again for the this op-amp circuit. Suppose this is the op-amp 2 and this is op-amp 2, op-amp 1 and op-amp 2. Then output of the op-amp 1 will be reflected to the input side, means this node, negative terminal of the op-amp 2. Then you have to use another solve again for the op-amp 2 to get the final V output here.
Sir, at the first node, the voltage is 2 volt or 0 volts.
No, uh, your voice is not clear. Can you take your mic at the your so that you can nearby so that you can speak properly?
At the first node, the voltage is 2 volt or 0 volts.
Here it is 2 volt. It is not connected to the ground. It is not grounded, so it will not be 0. And also it will not be equal to 2 volt because the 2 volt is not connected to this terminal. Okay, so that's why you have to assume some voltage to get. Okay,
Okay, sir.
yeah. Or you can see like this also. This is a simple manner to see this circuit. This is the 2 volt. No current is going into here into the positive terminal. So then it will be simply suppose this is 2 volt. This is the 1K and this is the same node as this. Suppose this is node A. So this is a node A and here it is 1 kilo ohm also and then grounded. By the voltage division principle also you can get this voltage. Okay, because no current is going here, no inside potential drop. So here if you see the 2 volts, so here it will appear as a 1 volt. Okay, simple method. Not going for the assuming some voltages.
How 1 volt, sir?
1 volt because here it is 2 volt, it is already there, and the other terminal is grounded here. So by the voltage division principle, it will be whatever the 2 volt multiplied by 1 kilo ohm divided by 1 plus 1 means basically R2 divided by R1 plus R2. If it is a this is a R1 and this is R2. So that's why it is equal. So that's why it became the plus 1 volt. This is a voltage division principle.
Simply we can say if resistance are same, the voltage is divided
Yeah,
equally.
yeah, you can say that. If it is a resistances are equal, just divide it by half.
Okay, sir.
Yeah.
11, sir.
11 volt. Okay. Re-verify again. 11 volt. 11 volt is correct. Okay. 11 volt is correct answer. Just wait for one more minute, 1 2 minute. Let's other also to solve. Okay, listen here. Let me give the solution for this. Okay. That is the same similar method that give us the voltage division principle. You will get the voltage here as a 1 volt basically. This, let me take another pen. So this will become plus 1 volt. Okay. So through the virtual ground concept, this voltage here at this node also will become 1 volt. Okay. Let's take it as a node B. Let's apply the KCL at node B. If you apply the KCL at node B, it will simply become 1 minus V input divided by 2 kilo ohm plus 1 minus V01 divided by 2 kilo ohm is equal to 0. Okay, because the current will directly flow from here to here. Okay, so the V01 will become V01 will be simply equal to 2 minus V input. What is the value of V input? V input is already given, that is the minus 3.5. So it become V2 minus 3.5, it will become 5.5. Okay. Now 5.5 will appear here. This is the 5.5 volt. Let me take another pen. So it will get reflected at this node also through the virtual ground concept. Whatever the voltage which is there at the V01, it will get reflected at here. Okay. Now, no current will flow into the negative terminal and also no current will flow into the positive terminal. That's why if you see this circuit will be simply looking like this. So this is op-amp circuit here, kind of, and this is the V output here, and this is the one resistor, that is the 2.2 kilo ohm, 2.2 kilo ohm, and this is the also the 2.2 kilo ohm, and which is grounded. Okay, so here this voltage which is there appearing, it is 5.5 volt. Okay, by the voltage division principle, you can say that this 5.5 will be equal to V output, this 2.2, R2 divided by R2 plus R1, R2 plus R1. So this is simply equal to V output by 2. So the V output will be 2 times of 5.5. Then it will be equal to 11 volt. This is the correct answer. Okay. Any doubt in this? Just you have to use the virtual ground concept, getting the output from the one op-amp circuit, then using for the other op-amp circuit. If you are facing any doubt in this, just let me know. Any doubt? Okay, if you don't have any doubt, let's proceed further. Try to solve this problem. There are four options. Four options are there, one, two, three, four, and one op-amp circuit is given. Okay, simple op-amp circuit, and the R1 value is given. This R1, this R1, this R2 value is given, and V input is also given. It is in the zero point 0.5 sin omega t. It is asking that there are four statements, and you have to see which statements are correct. 1, 2, 3, 4, or 1, 2. There will be multiple options can be correct. Okay, try to solve and let me know.
Option 3 and 4.
Option 3 and 4. Okay. Verify whether other options can be correct or not. Okay, option 1 is correct. Okay. Multiple answer can be correct. Okay. Check for the other options as well. Take time and solve for the check for the other options also whether they are correct or not. Okay, let me give the solution. Okay, option 1, option 4. I got the two answers that option 3 and option 4, and one other option that option 1 and option 4. Okay, so let's check whether which options are actually correct. Okay, if you see for the first option, if you see for the first option, what I have told that if I always assume that the it's a always given that it's a ideal op amp. Ideal op amp means the internal circuitry how it will look like. This is positive, this is negative. So it will be simply like this. So this is V input and this is the node P. Okay. So this is always very high. Ideally it is infinite. So that's why no current will flow here at the positive side also, no current will flow at the negative side. What it means? It means that whatever the current will flow through the R2, it because it is not going here in the negative side, so it means that the all current which is flowing from the R2 side will flow through the R1 and then flow to the output node here. Okay, so it means that option 1 is correct. So the current, whatever the current was flowing through the R2, and the simply same current will flow to the R1 because it is a ideal. Any doubt?
Sir, but R2 is not connected to every source.
This register, how it is connected?
Series.
Okay, series. Okay, so it means that that's correct. Because here there is no voltage drop, so that's why they are in the series connection that R2 and R1. That's why the same current will flow through that. That's true. Okay. So if you because this is the VI here, suppose this is the VI here, this is the V input. The same voltage will appear at the node P through the virtual ground concept, that is the VI. Let's apply the KCL at node P. So at node P, Vi minus 0 divided by R2 plus Vi minus V output divided by R1 will be equal to 0. Or you can say that V output simply equal to uh, V output here, R1 you can multiply there. So it will simply will become 1 plus R1 by R2 times of V input. Okay, or you can apply the voltage division also. So it will be simply like this. This is R1 and this is R2 here. This is grounded, and here at this node this is a V output. So the VP Vp is the voltage which will be equal to V output times of R2 divided by R2 plus R1. Or simply you can say that V output is equal to Vp times of R2 plus R1 divided by R2, or simply you can write it as V output 1 plus R1 by R2. Okay, so the option 2 is actually incorrect. What about the amplitude of the output when it is given? That's true. Option 3 is actually correct. When you put the value, V output is equal to Vp times of this is something. Okay, Vp is equal to V output times of something like this. So let's take that. If you know that what is the voltage at the input side, we know that what is the voltage at the input side. It's a zero point 0.5 sine omega t. Let's take another pen. So V output, we already know that it is a 1 plus R1 divided by R2 times of V input. Okay. Let's put the value. V output is equal to 1 plus, what is the value of R1? R1 is 3. What is the value of R2? R2 is 1. And simply multiplied by Vi. It means that it is 4 times of Vi. Put the value of Vi. Vi is
Sir, how you are telling V naught equal to 1 plus R1 by R2?
this is simply when let me make you understand. Let me duplicate it. Next slide. Second. So it is saying that it simply is a circuit is something like this. So this is the V input, and this is actually the some value correct here, and this is the V out. So it was saying it was positive V input. This is the negative. Okay, and this was grounded, and this was equal to simply equal to R2 here and the R1 here. Okay, so what I'm saying that this is the VP. Okay, VP means when you apply the KCL at this node, at node P, always I assume that the current is out of that network node basically. So no current is flowing here. So current here is zero. So when you apply the VP node, means KCL at node P, it will be simply equal to VP minus 0 by R2. What is the current which is going to the R2? And the second current which is flowing to the R1. Okay, that is simply equal to VP minus V output divided by R1 is equal to 0. When you take the Vp common, it will be simply equal to 1 upon R2 plus 1 upon R1, okay, is equal to V output by R1, okay. Take R1 that side, it will become V output is equal to R1 times of Vp 1 upon R2 plus 1 upon R1. Multiply R1 inside, you will get Vp times of 1 plus R1 divided by R2. Got my point? How we have got the V output is Vp times of 1 plus R1 by R2. Any doubt?
Yes, sir.
Okay. So the V output is equal to Vp times of means Vp is simply equal to Vi through the virtual ground concept. So that's why we have kept the value of R1 and R2. We have got 4 times of Vi. Now we are keeping the value of Vi. 4 times of Vi. 4 times of Vi means zero point 0.5 times of sine omega t because the Vi is already given. So it will be equal to 2 times of sine omega t. So if you see this circuit, it is a AC circuit whose amplitude is 2 and the frequency is omega. Okay. So the option 3 is also correct because its amplitude is actually 2. Okay. And also you can see here it also the fourth option. Fourth option is also correct because V input was zero point 0.5 sine omega t. Okay. And the V output which we have got, it's actually 2 times of sine omega t. They are actually in the same phase. Okay. One input is also in the sine omega t terms. V output is also sine omega t plus 0. Suppose this is omega t plus 0, omega t plus 0, this also. So the put means the phase difference between the both the circuits is actually 0. So they are in the same phase. So the option 1, option 3 and option 4 is correct. Any doubt in this?
Sir, once again share the page.
Uh, can you repeat what you have asked?
Clear, sir.
Okay, okay, fine. Let's move to the further some of the other problems as well. Try to solve this first. Let me zoom it. Try to solve this. Here, it is not given directly the voltages V1 and V2. It is being asked in terms of the V1 and V2. Okay. Try to solve and let me know which option is actually correct. Okay, option 4 I have got answer. Okay, let's wait for others also, and meanwhile you can verify your answer. Let's wait for 1-2 minutes more, and meanwhile you can verify. Okay. Okay, let me give the solution. Okay, I think. Meanwhile, whoever is solving, listen here. Okay, in the similar manner, which by the way we have solved the other problems. Okay, the same method we will apply here as well. So, if you see the positive terminal is actually grounded, so that's why we keep this negative terminal, which is the node which is connected to the negative terminal, also grounded through the virtual ground concept. If it is as a 0 volts, let's apply the KCL at node A. If we apply the KCL at node A, what it will become? It will become simply 0 minus V1 divided by 10 kilo ohm plus 0 minus, suppose this is the voltage is not given, let's assume that it is a voltage V dash. Okay, 0 minus V dash divided by 20 is equal to 0. So V dash will be simply equal to minus 2 times of V1. Okay. Now the thing is, we know the value of V dash in terms of the V1, that is a minus 2 times of V1, and we wanted to know the value of this V output. Okay. If you see the other op-amp, this op-amp 2, here also the positive terminal is actually grounded. So the negative terminal node will also will become as a zero potential. So let's assume that this is node B. Then apply the KCL at node B. Suppose if you apply the KCL at node B, it will simply become 0 minus, because this is at a minus 2 volt. So it will become minus 2 V1 divided by R3. R3 is 10 kilo ohms plus 0 minus, because this is also a one path, no? So this will also be one path and this will be also one path. Okay. So this is a zero potential. So similarly, this is also at the zero potential. So 0 minus V2 divided by 10 kilo ohm, this 10 kilo ohm, okay, plus 0 minus this loop, this feedback loop, V output divided by 20 is equal to 0. What you will get here, you will get plus times of 2V1 divided by 10 minus V2 divided by 10 is equal to V output divided by 20. Multiply 20 both sides, you will get V output is equal to 2 times of 2V1 minus V2. It is simply equal to 4 times of V1 minus 2 times of V2. Okay, so the option 4 will be the correct. Okay, any doubt in this? Don't be scared of the if you see the two multiple op-amp circuit. If it is a multiple op-amp circuit, that circuit will be more easy to solve. If it is a simple circuit, then it can be complicated. Any doubt in this?
No, sir.
Okay. Okay, then let's move forward. Let's try to solve few more problems. Try to solve this question. In this question, there is a one catch. Catch is that it is being asked the input impedance, not the gain. Okay. This is input impedance means what is the V input divided by I input. This is simple problem. Try to solve this. Use the same concept which I have told. Okay, option 2, I got one answer. Let's wait for 1 more minute. After that, I will give the solution. Okay, listen here. Okay, stop solving and let me give the solution. Okay, so if you see here in this problem, this positive terminal is basically connected to the V input here, V input. So this terminal, this node, suppose this is node A, this node potential will be simply equal to V input. You see, because this V input is directly connected to this node. Okay, then this same voltage will be reflected at this terminal also through the virtual ground concept. So this will also become V input. Okay, and the thing is, no current will flow at this negative terminal also, the positive terminal also. Okay, so simply the circuit will look like something like this. So this is the op-amp output. Suppose this is the V output. This is the R1 and this is the R2. And this node voltage which is there here, it is simply equal to V input. Okay. So the voltage division principle, you can say that V input is equal to V output R2 divided by R1 plus R2 through the voltage division principle. Okay. Now we have got the value of the V input and V output, means voltage gain ratio, gain basically V output by V input. But we needed to solve for the Z input, that is equal to V input divided by I input. It means that we need the I input value in terms of V output to keep the value at the place of the V output in terms of the I input. If you see the circuit, if you see the circuit here, this circuit, if you see this circuit here, if you see this circuit, if you see this circuit here, okay, the current which is flowing here at this node A, because no current will be here in this side, so the all the current will flow through the output side. Okay, it means that the I input which is flow coming from here, the same current will flow through the Z input also, because no current is flowing into the positive terminal. So you can say that through the current voltage PV principle, that KVL principle, the current I input is simply equal to V input minus V output divided by Z. Simply the current means current which is flowing through the resistor is equal to the whatever the voltage difference appearing across that impedance. Okay. Now we have got the V output value. that is the V output value in terms of the V input. Or you can say that now the thing is V input we needed and V output we already know. V output know here will be seen from here that V input is equal to V output times of R2 divided by R1 plus R2. Now keep put the value of V output from that equation to this equation, this I input equation. It will simply will become V input minus V output is equal to V input R1 plus R2 divided by R2. Okay, divided by Z. Okay, just I have kept the value of V output from equation 1. Suppose this is equation 1 and this is equation 2. From the equation 1 to the equation 2. It will simply will become V input minus V input. If you see like this, it will be written as R1 plus R1 by R2 divided by Z. Or you can write it as the V input get cancelled out. It will become minus V input times of Z multiplied by R1 divided by R2. Okay. Or you can write it like this. V input will become, sorry, 1 by Z basically. So the I input we have got minus V I input basically. I input we have got V input divided by Z multiplied by R1 plus R2. What we need? We need the value of Z input. Z input is simply equal to V input divided by I input. Okay. When you take the ratio of this V input divided by I input, you will get minus times of Z multiplied by R2 by R. Okay. So the option 2 will be the correct. You just have to think that what you have and in what terms you wanted the answer. Okay. So that's more
Sir,
important. Yeah.
like these questions will come in exams.
See, this I am just getting some extra thing, not for the assignment, not for the exam. Few more things, whatever the concept you will learn, you should understand that what kind of question can be found from that concept. Okay? If you know the things that then it will be a plus point. If it could come in the exam, then what you will do? Okay? So you will be already knowing that these kind of concepts are there. That gain we have to find it out. Then in adding the one more term that if it could be asked that find not the V output by input, find out the value of V output by I input. Then what you will do? If you know the way it could be solved, it will be easy for you. Okay? Are you getting my point? The questions which will come in the exam will be on a similar pattern of the assignments. Okay? Then try to solve this problem.
Yes.
Try to solve this. This question is not that much difficult. Okay. Uh, Use the concept which I have told. Okay. Assume some voltage here. Use the voltage division principle and reflect to the other side and get the V output.
Minus 309
Okay.
millivolts.
Minus 3 volt. Millivolt, I think. Okay. Mm. Let's wait for 10 more seconds. Okay, minus 0.399. Okay, let's see. Let's see whether it is correct or not. Let's solve. So if you see what I have told, the same concept through the virtual ground concept, and also it's a op amp, it ideal op amp. So no current will flow into the positive terminal and also the negative terminal. So if you apply the KVA, voltage division principle here, it will be simply like this. This is the 10 kilo ohm resistor, and this is the 100 kilo ohm resistor. This is grounded, and the V2 is here. Okay. So if you see what is the voltage as this node, suppose this is node A. What is the voltage as node A? Suppose so VA will be equal to V2 multiplied by, suppose this is R1, this is R2. R2 divided by R1 plus R2. Okay. What is the value of V2? V2 is simply 50 millivolt. And what is the value of R2? R2 is 100 kilo ohms. And what is the value of R1? R1 is simply 10 ohm. What it will come out? It will come out to be 50 millivolt multiplied by 10 by 11. Okay. So the same voltage, suppose this is the VA, same voltage will appear here at the negative terminal also, that is the VA. Let's apply the node KVL at node B. Suppose this is node B. Let's apply the KCL at node B. If you apply the KCL at node B, it will be simply equal to VA, whatever the voltage which is appearing at node B, VA minus V1 divided by 10 kilo plus VA minus V output divided by 100 is equal to 0. Okay. Let's multiply 10 in the numerator and denominator to make the base same. When you see here, the base is actually 100 currently, and it will become 10 VA minus 10 V1 plus VA minus V1 is equal to 0. What it will come? It will be 11 VA is equal to, sorry, this is the V output. VA 10 minus VA, and this is the V out. VA minus V out. Means 11 VA minus 10 times of V1 is equal to simply V output. So this was the value of the VA from the equation 1. Now it is the equation 2. Put the value of equation 1 into the equation 2. So the V output will be simply equal to 11 times of VA. What is the value of VA? It's a 50 millivolt multiplied by 10 by 11 minus 10 times of V1. What is the value of V1? It's a 10 millivolt. Okay. 11 will get cancelled out. It will become 500 millivolt minus 100 times of millivolt. It is simply equal to the 400 millivolt. This is simply equal to the V output. Okay. Let's verify whether it is correct or not. VA we have got V2 R2 divided by R2 plus R1. That is simply VA is equal to V2. V2 is 50. 50 multiplied by 10 divided by 11. Here it is correct of equation 1. At node 2 we have applied VA minus V1 divided by 10 plus VA minus V output divided by 100 is equal to 0. Then 10 times of VA minus 10 times of V1 plus VA minus V output is equal to 0. V output is simply equal to 11 times of VA minus 10 times of V1 by keeping the value 11 times of 50 millivolt. 10 divided by 11 minus 10 multiplied by 10 millivolt, because the V1 value is 10 millivolt, it is simply equal to, get cancelled out, 500 millivolt minus 100 millivolt, it will come out to be 4 millivolt. That is simply equal to the 0.4. Okay. Any doubt? Point 4 is the correct answer. Not minus, it's actually the plus, not minus. Okay. A similar manner which we have solved that taking the virtual ground concept, if it is a voltage is not given in that circuit, assume some voltage and then replicate to the other circuit. Okay. Let's try to solve this. Try to solve this problem. Here there is a one catch. One catch is that the circuit is not ideal circuit here because there is a linear circuit, linear region in between. So that's why it is plus 15 volt as a saturation voltage and also minus 15 volt as a saturation voltage. What is asking here, if output saturation voltages are the 15 volt and the minus 15 volt, the upper and lower threshold voltages for the circuit. What do you mean by upper and lower threshold? It means that what is this is the suppose this is the V output and this is the V input. So what is the value of the V input after which it gets saturated? Okay, that threshold they wanted to ask. It means that this point of the voltage and this point of voltage. Okay, then what you have to do? You have to make a equation V output in terms of the V input, some factor, suppose I am getting, put the value of V output at 15 volt, then you will get one answer as the V input, that will be upper threshold. Then keep the value of the V output as a minus 15 volt, then you will get the another threshold of the V. Okay, lower bound. Because we are equating the output to the minus 15 volt, that is the point after which it will get saturated. Okay, try to solve by this method. First step is to find the value of V output in terms of the V input, then keep the value of the V output as a saturation voltages, plus 15 and thus minus 15, and get the value of the upper and lower threshold values.
Sir,
Yes.
here which is R2 and R1? Sir?
Here there is a no concept of R2 and R1 here. So here that is a problem with the when you go by learning the process. Okay. Don't go by learning the process. If the circuit is coming like this, suppose this is the some circuit coming like this. This is the R1, this is the R2, this is the V input. Okay. Then that voltage division principle will be applicable here. Okay, are you getting? There is a no voltages in this circuit. Only one source voltage is there. Here you can apply the voltage division principle, but you are having here the one more voltage that is 3 volt. Then you cannot apply the voltage division principle here. Then you have to apply the KCL at this node. This node. Suppose this is node A. Apply the KCL at this particular node. Getting my point? Because
Yes, sir.
this is a scenario that this V input will get reflected at this particular node and no current will be flowing in this path. Okay, then it became easy to make a KCL equation and getting the values of the V output in terms of the V. Okay, apply that and let me know.
So if one another voltage source is there, I know we can't apply voltage dividends.
Yeah, voltage division principle is simply one circuit which is there and there is a no source is there. Okay. And the whatever the voltage which is coming, it will get directly divided. Okay. Let me give you one equation, one example of that. Let me give me one example. So let me take a blank slide. Suppose I am having a circuit like this. Suppose this is a plus 5 volt and I am like this, I am circuit. And this is the V output it is being asked. And this is the some value of the R1 and this is the R2. Now you can apply the voltage division here. So what will be the V output? V output is simply 5 volt R2 divided by R2 plus R1. So what is the value? Which will be the R1? R1 will be which is connected to the source directly. Okay. Now if the circuit is like this, suppose this is 5 volt, this is R1, and this is the 3 volt I have connected here, and this is the R2. Then if it is asked that what is the value of the voltage here, V output here, then you cannot use the voltage division principle here. Okay, now you have to what you have to find out the current. Current 5 minus 3 divided by R1 plus R2, that is equal to simply 2 divided by R1 plus R2. And then what is the value of V output? It is simply equal to 3 volt plus the voltage drop across the R2, that is I times of R2. I you have already find it out, 2 divided by R1 plus R2, it will be simply equal to 2 divided by R1 plus R2 multiplied by R2. Okay, so KCL is a fundamental and voltage division principle is derived from that KCL equation.
In previous equation,
Previous
why,
question, yeah,
how, why you used mesh methods?
yeah, that's true. I have used the KVL basically, KVL in this part. Okay, try to solve this. This could be a last problem of this today session. You have 2 minutes to solve. After that, I will give the solution. Okay, I got one answer -7 and 3 means option 3. Okay, let me give the solution. Okay, if you are facing problem, let me give the solution. Okay, so through the virtual ground concept, that is simple that this V input will be reflected at the positive in the node which is connected to the positive side. So this is the node which is connected. So the voltage of the V input will be reflected at this node A. Okay, so the node voltage at VA is simply equal to V input. Okay, let's apply the node KCL at node A. Always assume that the current is leaving that node. It means that it will be VA minus 3 divided by 5 kilo ohm plus VA minus V output divided by 10 kilo ohm is equal to 0. Okay, let's take the LCM. This will be 10, 2 times of VA minus 6 plus VA minus V output is equal to 0. It means that V output will be simply equal to 3 times of VA minus 6. What is the value of VA? VA is simply the 3 times of V input minus 6. So what you have got the value of the V output in terms of V input is 3 times of V input minus 6. That suppose this is equation 1. Now what I have told, because the circuit for getting the threshold, you have to equate the value of the V output because this is the V output and V input. It is being asked that what is this voltage? Suppose this is V1 and this is the V2, after which it gets saturated to the 15 volts. Okay, 15 volt and minus 15 volts. Okay, so for finding the value of the V1, for V1, assume that the V output is equal to 15 volt plus 15 volt. Keep the value in the equation 1, you will get V15 is equal to 3V input minus 6. What is the value of V input from here? It will come. It will come 21 divided by 3 is equal to plus 7. Let's take for what is the value of V2? For V2, V output is equal to minus 15 volt. Keep the value here. Minus 15 is equal to 3V input minus 6. So V input will be simply will become minus 9 by 3 is equal to minus 3 volt. Okay, so the correct option it will come option 2, not option 3. Getting my point? I think you have just negative, you have taken the negative of that. Okay, so the correct answer will be 7 volt and minus 3 volt. Any doubt in this?
This is ideal amplifiers.
Yeah, so here it is not written that it's ideal. So if the question is in the question itself it is written that it's a ideal, then assume that the ideal. Because in this question if you see here, in this it is specifically being mentioned that it is ideal. But here it is not being mentioned. If it is ideal, then circuit, this transfer function will look like something like this. There will not be any linear region. So it will be simply plus V set and minus V set. Okay, no linear region. But linear region will come in the non-ideal circuits. Getting my point?
Yes, sir.
Yeah. So these are the problems which is helpful for solving the assignment. Let's see that what kind of questions are there in the assignment. If you see this problem, the assignment problem 1, that is simple circuit which we have seen currently. We have seen this problem that is similar manner of this assignment one, first problem of the assignment 1. Okay. If you see the assignment 2 problem, that is of the similar manner. Checking that key, assume some voltage here and then reflect to this point and get the value of V output. Here also, if you see, there is a 2 volt. Okay, this is the 2 input amplifier. 3 volt also there, 3 volt, 2 volt is also there. Okay, you don't have to worry about that. Whatever methodology we have followed, just you have to use there. Simply for this question also, that is similar manner. Use the same concepts here also in this problem also. That is the easy problems. Okay. If you see here, this is the 2 volt that will be reflected here. This is the also 2 volt. Now you will get the output voltage easily. Okay. Simply equate the current here, what is flowing here. I will be simply equal to 4 minus 2 divided by 5 kilo ohm is equal to same current will flow through the feedback that is equal to 2 minus V output divided by 2.5 kilo ohms. Equate both and you will get the V output. Okay. Simply the same circuit here also, the same concept we have to use. This is also the V output because it is connected to the same node. Reflect here, this is also V output, and then apply the KCL here, KVL here, the KCL here at this node, particularly at the V output, you will get the answer. Similarly, the other problems also, I'm not going in the details of that. Whatever the concept I have given, you will be easily able to solve the assignment problems. Okay. Any further doubts? Any further doubts?
Yes.
Okay, I will upload the slides on the particular means folder, whatever Excel folder. Then try to look into that, and it will be more than enough. Whatever I have taught for the today's session, that is more than enough to solve the problems of the assignment and also the solve the problems of the exam as well. Okay, so that's all from today. And we will meet on the Saturday for the revision session. Basically, it is of 2 hours, and we will take the questions, variety of questions from the all the topics, few problems to go through the concepts of the whole syllabus. Okay, okay, that's all for today, and have a good day.